Last week, we introduced the cross product. This is our second version of vector multiplication. Here we have a vector cross a vector gives us a vector, opposed to the dot product, which was vector dot vector equals scalar. We care about the cross product because the cross product is orthogonal, which is perpendicular to the two vectors we're multiplying. A cross B is perpendicular or orthogonal to both A and B. We care about this because we're going to be working in R3 a lot. And we can describe the plane containing A and B with one vector rather than two vectors. I need two vectors to describe I can use two vectors to describe the plane by saying it's the plane containing A and B. I can describe the plane with one vector by saying the plane is everything perpendicular to this normal vector, A cross B. So what we're saying, another way of saying this is that A cross B is normal to the plane. That just means A cross B is perpendicular to the plane. A cross B is orthogonal to everything in the plane. So it's like we have three words to describe this vector being perpendicular to the plane. But you can't use normal in the same places you can use orthogonal and perpendicular. Say two lines are perpendicular, two vectors are orthogonal. You wouldn't want to say that two lines are normal. Any questions before we get started? If you would recall, we had a way to calculate A cross B, which was to calculate a determinant. So A cross B is the determinant of this matrix, where the first row is just ijk, the second row is a1, a2, a3, the vector A, and the third row is the vector B, b1, b2, b3. So notice that these two rows here, a1, a2, a3, b1, b2, b3, these two rows are made up of scalars, but we do have these unit vectors across the top row. Then we expand, multiply, calculate, work out, deal with, simplify. I'm not even sure what verb goes with this. We calculate the determinant using cofactor expansion across the first row. So the I components of the cross product will be A2B3 minus A3B2. If we think of I as being a 1, it's in that first column. Think of it as the 1. Notice that the subscripts on A and B are the 2 and the 3. Notice that the subscripts never match. So I use A2B3, A3B2. And for the I component, A2 goes first. The way that I calculate the cross product is to subtract because I'm following the alternating pattern that we follow in determinants for reasons. It's one of those things that you don't get to know until later. Students are like, well, why do we alternate the signs? And I'm like, well, because we do. And then students are like, oh, why do we alternate the signs? I check the teacher playbook for how to explain determinants at the beginning. And it just says, because we do, in parentheses, say more forcefully. So the students are like, well, why do we alternate the signs? And I just go, because we do. And everybody's like, oh, okay. So we alternate signs. The first one is plus, the next one is minus. The reason that I like subtracting the next one, because it will follow the same pattern. Think of J as the 2. So I'm going to go A1 B3 minus A3 B1. I like this better because it's following the same pattern. J is the 2, so I'm going to have 1s and 3s. I start out with A1. They never match, so it's A1 and B3 minus A3 and B1. Then the third one is back to plus because we alternate. This is going to be the K component. K is a 3, so I'm going to be using 1s and 2s. So A1 B2 minus A2 B1. So we can recognize this pattern. That'll help us remember how to calculate the cross product. This is a handy thing to remember, but it's unlikely that you're going to be called upon to calculate a bunch of cross products by hand quickly. But you should still know how it works. Kind of like parallel parking. You can live your whole life, even living in a city, and avoid parallel parking if you want. You're just not going to park on the street unless it's like diagonal parking spaces. And just say, well, I don't get to park here because I can't parallel park. You just live your whole life that way. Just parking in garages and stuff like that. But you're a better driver if you can parallel park. Of course, now cars will do that for you. So sometimes when you see this middle term, they'll distribute the negative. So that one goes backwards. I don't know why I like this less, but it'll say plus. And then the coefficient will be A3 B1 minus A1 B3. I know why this bothers me so much. I don't know why it should bother me so much that it doesn't follow the pattern. 2 3 3 2, 1 3 3 1, 1 2 2 1. I like that better than 2 3 3 2, 3 1 1 3. Then back to the other one. 1 2 2 1. I don't know. I don't know if my disdain for this particular form will infect you all, and later on you will dislike it and would rather have the minus out in front. I'm not even sure what my fellow Calc 3 teacher thinks about this. I wonder if we're setting up a battle between the minus and the just change the subscripts. The mathematical Coke versus Pepsi. So some of you might not like this 2 3 3 2, but then you have to change the order of the letters. So you can go A2 B3 minus B2 A3. So that might be the way that you happen to remember it. So you might prefer, instead of AB AB, you might prefer to remember it with A2 B3 minus B2 A3. I don't know, maybe you're an ABBA fan, and so you're going to go 2 3 2 3, 1 3 1 3, 1 2 1 2. Maybe you're going to like that better. If that's the case, you're in a category of student I like to refer to as weirdo. I'm just kidding. It doesn't matter how you remember it. I don't know why I do the letters and then the 2 3 3 2. Any questions? This is all hiding the real reason that I discuss all these different ways of remembering the cross product. Not because it matters, but because you need to observe patterns. And there are a lot of different ways of seeing what the pattern is. And so you can see all the different patterns before we just move on. Does that make sense? If you think, man, Leach, that's awful manipulative of you. Am I called? Yeah. Every time you walk into the classroom, the teacher is trying to manipulate you. This is a very manipulative job. I'm trying to get you to know stuff against your will. Anyway. So I don't know why I wasn't hearing me earlier. I just like mumbled anyway and heard that. But earlier I was saying full-on sentences in my regular voice and no captions. Take a moment to find the cross product of these two vectors. So we could say we've done it, not negligent in our duties. So this is a lot of pattern to remember. But our alternative to remembering this pattern in like letters and subscripts and all this other stuff is to remember the visual pattern that goes along with it. We're making a bunch of smaller determinants, the cofactors, and it would be A2B3 minus A3B2. So that pattern is what we want to know. We just want to make sure that we get the right two columns. So the coefficient of I will be 3 times 1 minus negative 2 times 0. 3 times 1 is 3. So that one came from 3 times 1 minus negative 2 times 0. It was blue earlier. So there's 3 up here. Came from 3 times 1 minus negative 2 times 0. Then we're going to subtract and do the next one. The next one, we're taking out the j column, so it'll be 5 times 1 minus negative 2 times negative 4. Oh, it's hiding behind the transcript. 5 times 1 minus negative 2 times negative 4. So 5 minus 8, which is negative 3. So negative 3j. That comes from 5 times 1 minus negative 2 times negative 4. And then for the k factor, I'm going to take out the third column. I'll go 5 times 0 minus 3 times negative 4. 5 times 0 is 0 minus 3 times negative 4 is positive 12. Everybody okay? Once you practice the actual calculation, you realize you don't have to remember this. You can remember the pattern visually, if that's how you happen to operate. So I remember it. I just remember these cofactors. It's times, and then minus, and then times. Any questions? So now we have a description of the plane containing the vectors A and B. So there's a plane with the vector 5, 3, -2, and -4, 0, 1. Those are two vectors sitting in a plane. The vector 3, 3, 12 is perpendicular to that that plane. So if I draw A and B, if I take a look at the plane, I've got a vector A and some vector B. I can't remember the angle between the vectors, so if we're looking down on the plane containing A and B, there'll be a line running perpendicular to this plane through where they connect. Actually, it can be wherever we want it to be. A cross B, since we're subject to the right-hand rule, A cross B, we'll put our fingers in the direction of A and curl the short way towards B. A cross B is coming out the paper. So A cross B points out of the paper. But if we have B cross A subject to the right-hand rule, we would point our fingers in the direction of B and curl them the short way towards A. And that means B cross A will point down into the paper. Oh, this isn't actually paper that I'm writing on. So if I wanted to draw A cross B, I would just start where they meet and I draw out of the paper. Oh, dang. I don't have my holograms on today, so it's only 2D. Now, B cross A is going to be drawn down into the paper, but I'm not allowed to cast spells higher than third level on campus. So I can't cast etherealness, so I can draw B cross A down into the table. So you're just going to have to use your imagination. Any questions? Etherealness, of course, being higher than third level. What level is etherealness again? Do you remember? 8th level. It's an 8th level spell. always, if you're recording your lectures, include some useless information. But then students will be sitting there during the test or the final exam and think about, dang it, why can't I remember the right-hand rule, but why do I know that ethylness is an 8th level spell? Can't I delete one and save the other? It's like, oh, clearly not, because spell level's way more important. When do I get to turn ethereal and walk through walls? Not until you get 8th level spells, which happens at what character level? Oh, come on. You guys just don't study, do you? I'm just kidding. You're like actually studying important things, not like D&D character levels. 15th, by the way, 15th level characters get access to 8th level spells. Why do we use the same word, level, for both things? Because Gygax was a jerk. I'm just kidding. I don't know if Gygax was a jerk or not. Actually, no, I've seen the Tomb of Horrors. He was a jerk. He was out to kill his players. That's just kind of a dick move. I like how the transcript censors me. It says it's a stick move. Now it's giving me tactics. It's stick, comma, move. Stick and move. Stick and move. It's giving boxing tactics, I guess. I think low key, Zoom is throwing shade on my enunciation. Zoom is throwing shade on my enunciation. Is that the right enunciation? Pronunciation? Sine, cosine, and tangent? 2 out of 3 ain't bad. No, 2 out of 3 ain't bad. No, bad. Yeah. It's even asking the questions like, is that what you said? Zoom is like, oh, I don't understand you. Where did you learn to speak English? Maybe I just have to be angry the whole time. All right, I will work on my diction. The rain in Spain falls mainly in the plain. Any questions on the cross product? So this is not exactly anything very fancy with regards to how we describe things. I don't want you to look at this describing a plane by a vector perpendicular to the plane and thinking this is some kind of weird thing. Remember, we're just trying to describe a direction that things are going in. We got away with a lot when we only had 2 dimensions because we were describing the direction that a line was headed. And so we used the slope, but the slope was one number containing 2 numbers. The slope contained a number for the rise and for the run. So if I write the equation y equals m I really don't like writing this way. Mx plus b is so ingrained, I don't like it and I can't get away from it. So here's the equation of a line containing the point x naught, y naught with slope m. But what we know is m is rise over run. So the slope is one number containing 2 directions. M is rise over run. So when the slope is rise over run, that's the vertical change between 2 points. Divided by the horizontal change between 2 points. So if I've got this line and I've got this rise and I've got the run, what is the slope that is perpendicular to this line? So if I have a line perpendicular, so here I had a 2 over 3, so I'm gonna have to go 3 over 2. So the slope of this line is the rise over the run. What's the slope of the line perpendicular? And perp. In terms of the rise and the run, what's the slope of the line perpendicular to the rise of this rise over run line? Well, this rise over run is positive slope, and this line is negative slope. So one of the things we have to do is change the sign. That's how we make a perpendicular slope. We change the sign. And what else do we do? Flip it over. We make a reciprocal. It's opposites and reciprocal. So it's minus the run over the rise. So the perpendicular slope is the opposite of the reciprocal of our original slope. Here I've drawn a rise of 2 and a run of 3. My perpendicular slope has a rise of 3 and a run of -2. Or I could have a rise of -3 and a run of +2. Perpendicular slope is minus the rise divided by the run. The run divided by the rise. Another way to remember this is that the product of perpendicular slopes is equal to -1. Rise over run times minus run over rise. The rise and the run cancel out, leaving 1, and the negative times positive is negative. Any questions? How's everybody okay? So let's just do a little bit of algebraic manipulation. So these two equations describe the same line, a line with the slope of rise over run containing the point x naught, y naught. Any questions? All right. Now what we want to do is upgrade this to the equation of a plane. What we've seen before is that the equation of a plane is a lot like the equation of a line. But now we have z equals z naught plus m times x minus x naught plus n times y minus y naught. We even know a little bit more. We know that this m should be the change in z with respect to x. And n is the change in z with respect to y. We want to rearrange this equation in the same way we rearrange the equation of the line. Now what we want to do is rearrange this equation of a plane in the same way that we rearrange the equation of a line. See what shows up. Then we want to decide, what do A, B, and C tell us? We can see that in the equation of a line, when we rearrange to a standard form, the coefficient of x is minus the rise, and the coefficient of y will be the run. So if I have a standard form of a line, if I think about the standard form of a line, it's not quite standard form. Standard form would be ax plus by equals c. But if I just multiply rise times x naught, run times y naught, put that on the other side, I get ax plus by equals c. A is the minus rise and b is the run. So this A is still the coefficient of X. That's still just going to be -1 times the rise. And this B is still going to be the run. That's just coefficients. So we want to do this same operation to go from this point and two slopes version of the equation of a plane to this kind of standard-ish version of the equation of a plane. And we want to know what these coefficients are telling us, and we want to make sure that it makes sense with what went on in the equation of a line. Any questions? Now we can make all this make sense right now, like instantly. If I just tell you right now what those coefficients are, but I have to do it right now. If I wait any longer than right now, then you just won't get it. We're just gonna have to go through this at the normal rate. It's just gonna be a big struggle. And if you didn't see what was coming next, then I mean, you just haven't been paying attention. Oh, look at the time. That's gonna do it for today. I will see you all on tomorrow. Have a good day, and thanks for playing. Stay cool.